it's really inspiring, especially the part about the why, right? Kind of doing some inward reflection, doing the talk on, my own why and things like that, right? So yeah, I thought that was pretty awesome. So lucky to have him come out. Is the mic working okay? Everyone can hear me okay? Okay, cool. Sounds good. We're going to give it just like one more minute for people to kind of come in if they want to. But thanks for coming out. And yeah, so yeah, all those inspirational quotes make me feel like I'm not doing enough with my life. Ready to quit your job? I don't know if that was the moral of the story, but okay, so it's 10:30 on my clock, so I'm going to get rolling. You guys are in the talk, Blue Cloud of Death. We're just talking about red teaming Azure environments. So everyone can hear me okay, I presume, and so I'm going to keep moving. So just pretend. Yeah, it's good enough, good enough. All right, project, gotcha. Okay, yeah, that's not a problem for me. I've been told I'm too loud. So just a little bit about myself. I'm not really, huge people person. So I used to work at Homeland. I worked in their security operations center, and I've led a bunch of their defensive hunting down APTs in the network, trying to get them out for quite a few years. And then I worked at NSA, and I was doing mostly offensive work, which is really more my passion. Kind of been, involved in hacking and the hacking scene since I was really young. So yeah, so, and then I worked at Adobe inside their Experience Cloud business unit, and I built out a red team capability there. So I worked there quite a few years. So I'm Bryce, and TweakFox is who I am on Twitter. After this talk, I'm going to take all the slides, push them up to SlideShare or whatever I'm using now, and tweet out the link. So if you guys want the slides, happy to share those. So now I am actually the president of Stage 2 Security. So we do a lot of red teaming against AWS environments and also some Azure environments. And then we also have some security engineers that help with securing those environments. So, and then also I lead BSides Salt Lake City. So I'm the lead organizer for that. So yeah, so yeah, things are good. I have a training at Black Hat. It is sold out, so sorry. And it will probably be at Europe too if you really want to go to it. So, all right. So we're just going to talk. I try to keep this pretty high level, and try to keep it pretty accessible. So, the cloud. Your boss talks about the cloud. This is what he envisions. It's just this one thing. But in reality, when you go to implement, you kind of realize it's a little bit more complex than that, right? So the way that I generally break up cloud is into 3 segments, regardless of the provider. You have kind of the portal portion, and that's what you as kind of the customer of the cloud sees and interact with. And then you have this kind of control plane, which is a lot of the APIs, and some of those are exposed to you as a user of the cloud, and some are kind of just internal use only. And then the data is kind of where all your data or VMs reside, right? So if you look at it from this perspective, the admin of a cloud portal logs into the web UI, he takes some action, that reaches out to APIs in the control plane, which then spin up or deploy services in the data plane, right? And then In the data plane, common services would be a load balancer, maybe some type of like Lambda AWS function or Azure function for an app, or maybe you're just using it to deploy VMs like you would ISaaS, right? Infrastructure as a service. And then there's often kind of a storage component there, like a S3 bucket or a blob storage for Azure. Yeah, so just FYI, I've kind of given a similar talk, which is all AWS focused a couple years ago, and that's on YouTube if you want to watch it. So that's at BSides 2017. So there's just an overwhelming amount of cloud services though. So we are not going to dive into every detail here. So depending on the customer and which services they're using inside of Azure's cloud, there's a lot of possibilities here. And each one of these kind of has their own security security concerns, right? So I'm just going to talk about the ones that I see most commonly used, right? And a lot of times inside the ISaaS, like the VMs, they'll have an agent which kind of reaches back to the control plane and talks via those APIs, right? So I don't know if you guys are, anyway, we'll talk more about that as we go into this talk. So we also oftentimes have this development pipeline that's built out, continuous integration pipeline, and developers are using this to push their code and updates to the cloud services. I don't know if you guys are probably aware of like Jenkins and other CI type tools, deployment type tools, right? Those kind of build your pipeline, and those are usually customized for each organization. And then lastly, but not really lastly when you're running a company, you have the users, right, which are accessing these services generally from the internet, right? All right, so that's kind of my Cloud 101 overview, high level. Now we'll dive more in the components. But just so you guys get some more perspective on the importance of securing this stuff, which, I mean, if you're at a cybersecurity conference, you probably are aware of this stuff, but there's some pretty funny things on the internet if you search, right? So like, if you don't properly manage access to these accounts, people can use your services and rack you up huge bills, right? I mean, maybe they'll knock it off because your account got hacked, but maybe you'll be responsible for it. So I've personally seen $500,000 in bills racked up. So, and then even worse is entire startups have been put out of business, right? So there was a group and they got access to a company's root AWS keys, which generally you're not supposed to use because it's really hard to rotate or do anything. And they just basically sent ransom, like said, pay us money or we're going to destroy all your infrastructure. And they kind of thought they were joking. And no, they went in and all their backups were also in AWS. So they deleted all their backups and they deleted all their VMs and destroyed the entire company. They went out of business overnight. So I mean, there's real world impacts for some of the silly stuff that you'll see in this presentation today. All right, cool. So, just starting out really high level, right? So you have developers and admins, and they're using services on the internet. We have, we live in a very SaaS, cloud-based environment, and people, they need to get their jobs done, right? But unfortunately, some users occasionally make mistakes, right? So they'll post code to GitHub, right? And the code will contain keys or secrets or certificates, which can be used to interface with cloud services, enabling some level of privilege. So like if you literally take that Google Dork and search for it, you will find people's keys on the internet right now. So it's not good, but yeah, so people make mistakes. So also sometimes you'll find similar type keys on Pastebin or other services. And so, just generally trying to build a solid CI pipeline and make sure people just make mistakes, right? So another thing is which we just kind of touched on, is the repos. But specifically, companies will say, okay, well, we're not going to use like a cloud service. We're just going to have like our own server, which is kind of like our, like Bitbucket or GitLab or something like that. But then they're spinning up, VMs inside the cloud up and down, and so they kind of make the access to that server pretty wide, right? So that's another scenario where I've seen. And the big thing is, you could affect that CI pipeline potentially, but oftentimes these also have secrets which allow you to interface with all the cloud services too, so you can go in and pull those out. So, which is what that screenshot kind of shows. So, and then more just going against the pipeline, which there's been a lot of talks about hacking Jenkins and other services like that. So generally speaking, you should have that stuff locked down so only developers can get into it, but anyways. And then just another thing we're not really going to dive into deep today on, but I just want to make you aware is this traditional attacks of hacking the client and leveraging whatever authorization they have to pivot back into the cloud still apply here, right? So like if the hacker can get access to an admin's box or a developer's box, whatever the developer admin can do, potentially if they are willing to spend the time and resources, the hackers can do too, right? So, and that's, as simple as, potentially sending macros in and waiting for people to run them or other common, type attacks, right? But then taking a more focused look when you get on the endpoint, what does this user actually do? Do they have access to any cloud services? Can we harvest those credentials? Can we reuse them? All that. So, all right, and then just this is my spaghetti map of all the ways you get pwned, right? So there's all those points that, if they're not all considerations and secure, then, you may lead to a doomsday scenario. Okay, so that's my intro. So we're going to talk for a minute about storage. And I spend some time talking about Azure storage because a lot of the other services and a lot of the ways you're going to build your cloud services are going to some way interface with Azure storage solution, right? So generally speaking, you're going to have an app, right, or your VMs, and if they want to persist data for a long time and share it, then they're going to use Azure storage solution, right, to do that. And maybe your ISaaS or your app is really just a web server or web app that's kind of feeding, letting users interface with it, but eventually the data is going to land inside this bucket or these storage containers. So if the hacker can get access to the storage, they don't really need to hack your app, right? They can kind of bypass and get the data directly. So, and there's different types of storage inside Azure solutions. The most common though is the blobs, so that's what we're going to focus on. That's kind of the Azure equivalent to S3 buckets if you're acquainted with S3 buckets in AWS. So, okay, and so I just want to kind of pull out. There's these three concepts here. So you have the storage account name. So that's something that's a unique identifier, right? Like if you tried to register that same name right now, Azure would not let you do that, right? Because it's registered to my account. And then inside of that, you create these container names, right? Which is kind of where you're going to be storing your data, like a folder. And then under those, you're going to have your file name, which is called blob name, right? So just kind of, we want to discover insecure or insecure blob storage, right? So the first thing we need to figure out is what is the account name, right? So that's it's like part of the FQDN, right? So we could take common tools for brute forcing FQDNs and try and brute force out storage names if we wanted to. So what I like to use is GoBuster. It is very fast at doing this type of brute force, and while still being mostly reliable, right? So, so that's kind of what I use, and usually I use that with a combination of like dictionary, but you could do a straight like brute force. So I started to try and do some of the computational math to just kind of do some metrics on how long it would take if you just wanted to brute force all of that blob storage space, right? Because you can only, right, sorry. So for the storage account name, you can only use lowercase letters and numbers, and it's got to be between 3 and 24 characters. So you can see, every time you add a character, the amount of time it's going to take to brute force all the possible storage account names goes up exponentially. So, and then if you get a hit and you figure out what the storage account name is, you still need to figure out what the container name is. And so you could also use GoBuster to kind of do a derby, like directory file guessing type attack to figure that out. And then you also need to figure out the names, but you can do an argument here, often if it enables listings to kind of list files if you get those other two parameters. So brute forcing all three of those is very, it's possible, and I've had some luck there on engagements doing some of that, but it's, if you can give yourself a leg up, that would be, there's an easier way to basically do this, right? So if you kind of look at it, oftentimes you'll have a web service, which is kind of linking to the storage, right? And sometimes it's like a full proxy where it's not letting you see where it's storing the data, but other times, due to efficiencies, it allows the user to kind of directly interact with the blobs, with the containers, this blob storage, so that it doesn't have to have the web app taking the load of uploading like large files all the time, right? And there is a way to issue secure kind of like limited use tokens so that people can seamlessly store stuff in blob storage. So we want to discover what that is. So I wrote this script. It's on the internet, and I'll tweet out a link to it too. And the first thing, all this does is you just give it an IP address, and then it goes and pulls these files, which basically have all the net blocks for AWS and Azure, and then tells you like, yes, this IP is Azure or AWS, and it's in this region. So it just helps you verify the target is actually what you think it is, right? Not anything you couldn't do by hand, but just kind of saves you some time, right? And then I wrote this other tool called Loris Love, and this is just a web spider. So it will just go through and spider the target website, and it will look specifically for AWS buckets and Azure storage account names, right? And then let you know what it is. So you can see in this screenshot, it spidered the website, it sees it's linking out to a resource, and lets you know what that is inside the log file. So now, if they link directly to it from the web service, that kind of gives you a leg up, and then you only need to brute force kind of some of the like file name type, blob names, parameters, things like that, right? So you can save yourself some time there. You could do a similar thing with, like if you use Burp Suite a lot to test web apps, but, and there is an extension for Burp Suite, but it doesn't actually support any Azure or like any other targets like DigitalOcean or whatever. So you'd have to add that in, and anyways, so. But this out of the box does support this, so. All right. Cool. So storage access, right? So we're the hacker here. We want to access storage. We've been able to find a certificate or some other type of secret, and we want to use that, right? So the first thing is Azure, as opposed to kind of AWS, it relies on these management certificates a lot to authenticate to the services. So you want to be particularly aware that anything like .publish settings type file is kind of an export and will also contain that certificate. So if you see any of those files, you definitely want to pull them back, and then you can reuse those to access, right? So you can also look for configuration files. A lot of times when developers are coding their like .NET apps, you'll find the web.config file, and if that's integrated with Azure, it will also contain like kind of either a SAS URI or a like access token, which you can use to access the storage. And I just wanted to kind of, because I guess this is kind of second nature if you do a lot of Azure work, right? But if you haven't actually used Azure a lot, I just wanted to make sure you guys realize this is like really trivial once you find those secrets to leverage, right? So you literally just go to Microsoft's website, you download the Storage Explorer, which is a free app, right? You boot up the app, and then it asks you when you boot up the app what type of credential you have. So you just kind of select it, and then you input the credential, and you just map down to those storage, and now you can start upload, download files, right? So it's literally that easy. There's some other third-party software that's a little bit slicker than Storage Explorer, but this is kind of the easy way to go, right? And kind of the Microsoft approach. All right, cool. So let's talk about VHDs. So these are virtual hard disks, right? If you've ever used Hyper-V or Microsoft's virtualization solutions, you might be acquainted with these. So they're very, like pretty much the same thing in Azure, right? So for most of the history of Azure, your VHD files were just stored inside of blob storage, right? So if you got an over-permissive access token for blob storage, you could literally go in and start downloading the virtual hard disks for the ISAS, the VMs, right? And when you download them, what I do is I do a lot of testing against Linux targets, right? Almost exclusively, right? I look for, SSH private keys. Those shouldn't be on ISAS VMs in the cloud, but you'd be surprised. And then also I look for password hashes inside shadow files. And I just kind of, I guess I didn't put the grep command, but I just kind of grep for $:1, $, and then to find the different hash types. Because you can forensically extract the files out of the VHD, or you can just grep and get the hash quick, right? So and then throw that into hashcat GPU type system and kind of break that. And so this, let's see. All right. So also it's important to review the code. I feel like a lot of the assessments that I've worked on in the past still have secrets hard-coded into the code base. So if you can get access to the code base via one target, generally those secrets will enable you more access throughout the subscription in Azure. So, okay, there I did put a string in there to grep. Okay, great. So grep for the secrets, and you can even use PowerShell to grep. So there you go. I'm more of like a Linux type guy. So, all right. But Azure, they've done a really good job with moving to this managed disk platform. But whether your particular target is implementing that or not, highly dependent, right? But with managed disks, by default, they no longer store the VHD files in blob storage, and this was rolled out like June 2017. So if you are actively using Azure, there's other advantages for using managed disks, but there's a slight security advantage here, right? So that you no longer have those VHDs in blob storage, and so even if blob storage is compromised, they can't download hard disks. So, right. So, okay, great. So that's kind of the find secrets, look at it from the storage angle, right? So you don't really, I don't know. As a guy who's been doing red teaming, offensive stuff for a long time, using web GUIs is okay if you have to, but generally speaking, you want to, I don't know, I'm more like a console type guy, right? So I just wanted to show you guys, if you got access to an endpoint, what you would look for on the endpoint to kind of get further access inside of an Azure subscription, right? So if you can get access to an endpoint, like the admin or dev boxes, oftentimes they'll set up this PowerShell CLI, which will allow them to interface with the Azure, the control plane, and throughout the services. So, a lot of times you'll see them do AZ space login, right, on the box, and then they can do tech username, tech password, but they can also just kind of copy and paste this URL and then log in using this token to their Azure, to the management portal for Azure. So once they do that, there's actually a cookie in the browser which gets stored, right? Which as long as that cookie is valid, if you pick that cookie off the endpoint, you could potentially, or you inject inside the browser using Cobalt Strike or something like that, you could kind of do a man in the browser type attack and also access the Azure subscription that way. So, oh yeah, steal the cookie, right? But then once the client gets authenticated, they get back this message, right? So that's all fine and dandy. But from a hacker's perspective, if I get access to a dev's box, I want to know how to replicate this, right? So So there's a .azure folder, right, under the user's profile in Windows, like users Bryce .azure gets created, right? And inside there, you'll get this Azure profile.json file, and that'll have information about the subscription. So you can go pull that back off the box, kind of get more information about the subscription. But the really cool part is if you're quick, you can actually steal these token files off the endpoint. And if you use those on your box, as long as there's no other mitigating controls, you can also access the subscription using that, right? These do have a TTL, they die, right? So this is more like a same-day type op thing, but it is possible to just pull those off. So I know someone's going to ask that. It's I don't know. Sorry. So I did know it, but I don't know right now. And then if you get access to subscription, I'd usually just do AZ account show, and that's kind of your who am I equivalent, right? Because a lot of times when you're pulling these creds off the box, you're actually not really sure who they belong to, so this kind of helps you out. So on the flip side, maybe you want to monitor for that on the Azure side, right? So usually users don't need to know who they are, right? So okay, all right. So data control. So I just kind of wanted to talk to you guys like. We're just talking about cloud kind of specific stuff in this talk, and I'm mostly trying to keep it focused on Azure, right? But there's this whole world of like pen testing and red teaming that I'm kind of completely ignoring, right? Which would be, you have an ISAS, like a VM sitting out there on the internet, right? If you can find some type of web application vulnerability, like an XXE or some other way to, get privileged information, maybe you can SSH into that ISAS server, right? Or maybe you can find some type of struts vulnerability and just get code execution straight through that app, right? And then when you're on that, though, that's cool, you're inside like a single VM, right? But that's not like super useful. So, because maybe that's not really your intended target, right? Maybe your target is some super secure server, but then maybe they have some test server sitting next to it and you get on the test server, right? But if you can pivot back up into the control plane, then you can probably use your access in the control plane just to pivot onto the target that you want to be on, legitly. So if you get access to a VM, right, Azure does have this metadata service that you can query. This is like really useful in AWS land. In Azure land, not so much, right? It doesn't return very useful information. It doesn't usually contain credentials. But there's that agent that we talked about that is installed on the VMs, and it does store configuration data under /var/lib/w agent, WA agent, right? So cool things is like when people task VMs for different extensions, like all that data gets logged under this directory, so you can see what the admins are doing, right? And potentially maybe the admins are even using the control plane to pass into the data plane, the VM, some like commands to run, and maybe those commands also contain more secrets, right? So you want to look there for that. There was actually a vulnerability reported to Microsoft, which they fixed, where if you enabled certain features in your ISAS VM, it actually also stored credentials in here by default, right? So like that was like an Azure mistake, right? But they've since fixed that. So anyways, I always go to that directory, troll through the files, try and find secrets, right? So that's like gotta try that, right? And then I just want to show you the reverse, right? If you can get a secret to the control plane, how would you get to the data plane? This is really just evil system administration, right? So, you have some access to the control plane, like either via the portal or via some API, and now you're just trying to get into the VM so you can get the data or more secrets, right? They have this slick feature in Azure called capture image. This is actually pretty slick. So you can capture an image of running, or depends on the VM type. And then you can download that and kind of do your VHD analysis like you would before. It's also kind of this technique, which is a slightly more complex in Azure than it is in AWS, but where I don't really recommend this, but if you power off a VM, you can mount the hard disk, then you can modify it. Like oftentimes I'll just add a SSH key, right? Because you can append multiple SSH keys into, if they're using that to authenticate to a Linux server, and then you can boot back up the VM. But in Azure land, generally you have to kind of destroy a lot of the configuration data for that VM, so you need to make sure you know what that all is, and then you have to go back and recreate that. In AWS, it's more seamless. And then Azure actually provides features to reset passwords if you have the right rights inside of the console, so you could technically use those, albeit they may be monitored by a defensive team, so use caution right there. So, okay, yeah, and you can actually load extensions, which the agent will load up, which will then let you to execute more commands. You can also use those to run custom scripts. Like the command here will download a script off GitHub and then run it inside a VM, so you can get more code execution there. So, all right, cool. All right, so persistence. We found some type of secret. We hacked a VM. We have some level of access, and we want to keep access for as long as possible, right? So we're like not doing pen testing now. We're doing more like red teaming, long-term engagement, right? We want to stay in, or nation statey, right? So let's say the attacker, we found some credential, and we were able to use that to access the blob storage, right? The first thing that I would do is I would generate a SAS URL, right? So if you just right-click inside of this console and generate an SAS URL, you can actually use this URL, and you can say it never expires, right? Or you can say it expires in 2 years or whatever you want. And you can use that URL to continue to re-authenticate to the blob storage, right? And yeah, you can revoke these, but you have to rotate your access token, which is kind of like higher up the chain. And generally speaking, orgs they're either really good at rotating those or more likely really horrible at it, right? So. And then if you're able to get access where you can modify any type of service principal, which is kind of like a really high level Azure type account, right? So you can actually assign multiple passwords to the same service principal account, right? So, it is technically viewable to the user if you go into the UI, but it's like pretty nested down there, right? So, but you can keep appending passwords or keys to that same service principal account, so. Yeah, so their password still works fine. Now you have like a skeleton key password, which also works with the account. So, so it is visible in the console, but it's pretty nested. Generally never gets detected. So, all right, let's see. Okay, sounds good. All right, so I just wanted to dig a little bit deeper. All that stuff that you've seen now, it may not really be common knowledge, but it's pretty straightforward. It's been out there in the space, and I just kind of wanted to dig a little deeper and try and show you guys something that probably a little crazy, like probably really shouldn't use it on a red team engagement, but it does work. So the agent that you have installed by default on most of these ISAS VMs, right? Well, how it operates is that it pulls from an API from the control plane for taskings, right? So periodically it makes this query, says, hey, control plane, is there anything you want me to do? It says no, and then doesn't do anything, right? Or does some type of process. And I kind of wanted to show you some of the tools and techniques I use to do this investigation. So like more like a teaching you how to fish rather than a giving you the fish type scenario, right? So so if some of this is a little basic, I apologize. I just want to kind of make sure all on the same page, right? So and you could go read documentation about how the agent works, albeit it's pretty loose. But you could also review the source code, right? So, so anyways, so you're on a box and you find a new process. You just run like ps aux f www. That's what I run, right? So, because it kind of gives you a process tree on most targets of what process was spawned by what other process, right? So we can see in the process tree that there's this WA agent process, right? And then we could also see that it's a daemon because it has a tac daemon argument, and that it's a Python process, right? So so we can use the file command to find out what type of file this binary is, and it lets us know it's not an ELF binary, it's just a Python script. So we could go in and do source code review. I would if you guys are really interested, I would definitely go look at the source code. There's some pretty interesting stuff. So, which I'm not going to talk about, but I will show you some cool stuff. So and then on the box you can also do netstat tac NL TPU to see what's listening, and NATPU to see what's active connections in the box. So we start digging, we see this unknown service, but we want to know more about what the service does on the Linux target. So we know it's Python based, right? So I don't know if you guys are aware, but Python has a debugger built into it, and it's it's pretty slick, right? So if you do like a tac M and then the PDB, you can load up the debugging module and you can step through the Python script, right? Because like if you look at the WA agent code, the script, it has a lot of different functions, right? But they don't execute unless certain conditions are true inside of the ISAS, the VM environment, right? So you might be confused when you're looking at the script because you see a particular section has a vulnerability or something really interesting. You're trying to figure out how to jump to it. So you can use the Python debugger to kind of to figure out how the code is working, right? And step through it. There's another project called Pyrite, which is really cool, but you do have to install some dependencies on the box. Nothing crazy, but like you have to have GDB working and a couple other things. But Pyrite's cool because, the Python debugger, you start the process and then you step through it kind of line by line, right? But Pyrite will actually inject your debugger into an already existing running process. So if you really want to get hardcore into debugging Python processes, Pyrite is like definitely the way to go. But this is good for most use case. So, and then I really like this tool called sysdig. I feel like not enough people know about it / use it. On Windows, everyone when they want to investigate Windows processes, you have the sysinternal tool suite, which I think a lot of people are acquainted with, and they use, procmon or something like that, and they'll get a full, like they'll start up procmon, they'll run the binary, they'll figure out everything that the process does, every registry key it touches, every file it makes, every network connection it makes, and they'll get a log of that, right? Sysdig is like that exact same thing, but over on the Linux side, right? And it's free to use, so, and you can usually just apt-get it, right? You usually just apt-get it. So, or use your package manager and install it. But basically you create these capture files. This is the way I use it, right? Like I create a capture file. I start a capture file. I start up the process. When I'm done doing whatever I'm doing inside the process, Control C, and then I'll read the capture file using tac C means carver, so that's kind of like a specific code that's trying to carve data out of it. Like you can use one carver to see all the network connections. You can use another carver to see all the files that were written to disk. And so you can start to build out that timeline of everything this process is doing on the box. Potentially you could even use this for like malware analysis type purposes, right? If you're trying to do analysis of like a Linux-based malware, right? So, I don't know, I think it's pretty slick. So, so we use sysdig on the proc. We see that the proc is storing a lot of data in /varlib WA agent, which we already talked about as far as like a place to look for credentials. And then, and we also notice it makes certain network connections, right? So we start up TCP dump and we just start capturing the network connections. So the way that the agent works is, basically, inside of Azure's control plane, they basically have, as part of the fabric for Azure, which is kind of their term for the parts of Azure that are outside the scope of the customer, right? So they basically have this magic IP, right? And so when you talk to this IP, you can talk to this API, and that's kind of an API specific for that, for VMs to talk to the control plane, right? So we just can filter, if we do a packet capture, we pull that back off the box, and then we load up TCP, why did I put TCP down? Wireshark, right? Then we can use this filter just to look at things talking to the control plane to that specific API. Okay, so we see there's the agent. When it starts up, it starts talking to this address and the control plane. That's a magic address. Don't get confused. It's not like it's something routable on the internet, right? It's something that kind of gets translated inside of the Azure's environment. So let's just talk about how this works. So we start looking at the packet capture a little bit more, right? And so we get a lot of these GET requests for goal state, right? And that's just it polling to see if there's a tasking, right? Like, is there something that the data plane wants me to do? Yes or no, right? And for the most part, it just returns back with a response, which basically means do nothing, right? So, but when we issued that command via PowerShell to execute a script on a VM, we got a different response. We got this incarnation equals 2 basically inside of an XML SOAP request response, right? So that kind of signaled that the agent needs to take a different, go down a different path of code, right? And so the agent, once it gets that response, it comes back, it pulls some host config data, right, using this GET request. And then it also pulls some certificates, albeit these are kind of like public certs. They're not, as far as I can tell, useful from like an offensive standpoint. So it's mostly to verify packages that are going to come down. So, and then it will actually get the config for the extension that it wants to run. So these are the commands that it's going to run, basically, right? So, and that's kind of the fourth part of the request, right? 1, 2, 3, 4. Yep. Okay. So kind of putting that all together, the journey, right? So imagine you're tasked, you're part of a red team, you're supposed to look at this SaaS environment, you do a bunch of OSINT, and you find creds in a repo, right? So it's honestly more common than it should be, right? But the goal is to get to this VM that's like, has the tiny red box around it, right? It's not accessible by the internet, but you know it's inside one of their Azure accounts, right? So then we can use the cred in the repo to access storage, pull back hard disks, and then find additional certificates that are stored inside configuration files inside the VHDs, right? So, and using those certificates, we can use those to access the subscription via the control plane. And then we can execute custom scripts on our intended target, right? So via the extensions. So you can see it's kind of a multi-step thing. But have you guys ever been part of, how many of you raise your hands have been a part of like a pen test before at an org, right? Like some of you? Okay, all right, okay. So from my experience, do pen tests generally stay secret at orgs? Or does eventually everyone find out a pen test is going on, right? So from my experience, a lot of times everybody finds out, right? So, and they find out what the goal is, right? So let's just take the assumption that the defenders know you're coming for this box, right? They know that you want to get on the box. So they've taken additional precautions on this particular target to fortify it, right? So they're doing file integrity monitoring on the box. So if you can't really modify any core files without it being detected and, you know, you being busted and being shamed to death, right? So, and then let's say they've got OS query kind of running on the box and it's monitoring all the running processes. So you don't want to start up a new process on the box. That would be unexpected, right? Because then, you know, they're going to find that, see it's your malware, and then get caught, right? And they're also watching your NetStack connections. So you don't really want to make a connection back to you on the internet, right? Because maybe you're not coming from a normal source. Maybe the server doesn't really even ever supposed to talk to the internet, right? So how would you practically do this? Are Are you guys mostly on the defense side? Raise your hands. I see a lot of nods. Okay, all right. So let's talk more about the practical, how you would implement this, right? So one thing that I've seen on Linux side that's pretty sweet is HubbleStack, right? And it's open source, so hubblestack.io. So it actually will do all these features for you right here. So specifically when I'm talking about bypassing, I'm talking about bypassing like a fully implemented HubbleStack implementation. And how many of you, raise your hands, have heard of Salt before, or SaltStack? Yeah. So all HubbleStack is like extension to Salt. So if you already have your Salt minions deployed, then you implement Hubble on top of that, and it uses that Salt infrastructure to kind of do all these security functions on your targets. So, and it's kind of designed from the ground up to send data back to like a Splunk or Elk type infrastructure. So that, I mean, this is going to be a side rant for a second. So as a red teamer, right, like oftentimes I get to the target that I'm going to if I'm persistent enough and I have enough time, right? But one thing that is truly scary if the goal is to stay in the network for a long period of time is when you have systems like this and they're sending data off to Splunk or Elk, there's a large amount of telemetry data about like processes and network connections which are being logged, right? If eventually anybody makes a mistake or the blue team eventually gets lucky and they find you on a box, they can kind of make a profile of what your TTPs look like, and they can use that telemetry data to kind of map back everything you did over the last year, right? So from my standpoint, you know, it's scary. We're kind of in this recorded future type status where in highly monitored environments, you know, it's not just did I get caught today, it's did I do something last month, which is also going to be linked together with what I did today, and is that important in the context of what I'm executing? So there's a lot more. I think as more and more gets recorded by telemetry and endpoint agents, like red teams and nation states are going to have to severely like up their games, right? So especially if they don't want to be attributed. So all right. So coming back to this talk, Azure. So trying to bypass all these type of features. If you want these features, check out HubbleStack, hubblestack.io. So, okay, so, but it kind of dawned on me. Sometimes I have these like crazy ideas, and oftentimes they work out, which is even scarier. So, I was like, I don't need to go install software on this box. This box already has an agent that's looking for updates. Like, let's just give it updates, right? So I use the credentials to make my own kind of beachhead inside of the target network, right? So kind of in the same logical network segment. You know, this is an environment where there's a lot of VMs, so spinning one more up didn't really matter. You don't have to do that to execute this, but that's kind of what I did here. So, and then I put my malware on that box just in case I lost access to the control plane or the subscription through the persistence methods. I just want to add another foothold, right? So, okay, cool. So that's kind of our setup there. So we have this beachhead. It's really common for attackers to do this. Generally for a beachhead, you're looking for something that's like of basically no value, right? As an attacker, you don't really care about it other than it's a pivot in the network. And generally you like to find ones that are poorly monitored or poorly managed, right? Because then you can be more liberal with what you do on it and not worry about getting caught, right? So in this instance, it'd be something that doesn't have like Hubble on it or all those monitoring tools, right? So, and then what you can do is, remember we can execute commands on the target, right? By having it run these custom scripts. So we have it execute an IP tables rule on the target, right? And the IP tables rule, what it does, it says, hey, on your outbound table, anytime you go to connect to this magic Azure Fabric IP, don't connect there. That's not where you actually want to go, right? You want to come on over to my server, my beachhead server, right? To get your communications instead, right? So that's what that IP tables rule does there. Now the really cool part about this is that when you look at the netstat, is you still see the 168 address, right? It doesn't, like the IP table happens after the netstat, so it's, yeah, blends in. And then it's not a process. I mean, if they're monitoring the IP table rules, then you would get caught, but if they're monitoring processes and network connections, this will fly under the radar, right? So, and then on our beachhead, just for, you could do much better than this, but just for example's sake, I used man-in-the-middle proxy on it, right? And I implemented this other outbound rule that just basically says, man-in-the-middle, so target sends data to that box. That data box sends it to the man-in-the-middle proxy process. And then when it sends the data out, another IP tables rule says you don't want to send that out to the internet. You want to send that back to the control plane, right? So that's kind of what that redirection rule does there on our beachhead. So, and then what we do is we go user access into the console. We say, hey, we want to run this custom script on the beachhead. And when that flow comes down through that data control, through the control plane to the data plane, that actually, via man-in-the-middle proxy, gets passed into our target, and then our target executes the intended command, right? And I just wrote a file out to /temp for this trivial example. But mitigations. So I'm horrible at mitigations, so I brought another person in for the training that's going to go over that. So sorry, I know most of you blue team guys, but the big thing, the takeaways here is like logging, right? So, I mean, from my standpoint, if you don't log it, like it's going to be really hard to catch it. And not today, maybe you won't catch it today, but maybe tomorrow, right? So there's ways to enable verbose logging in both AWS and Azure. And usually those get stored to blob storage. So make sure wherever you're storing that. A lot of times I recommend that's a completely different AWS or Azure account. But just make sure that's secure, right? You don't want someone to go modify your logs. Limit access, especially to pipeline stuff. Like no reason anyone needs to get to your Jenkins except for like your trusted office networks, things like that, right? So, and encrypt secrets, right? Like I don't understand why, but like oftentimes I'll often see code bases where parts of it have the secrets encrypted, and then other parts they're just plain text still. So fully rolling that out is pretty vital, right? So that's pretty common still. All right, thanks for coming out. I'm Bryce. I'm gonna post the slides using my Twitter, TweakFox. So if you want the slides, I'll post them up. If you need anything, just hit me up on Twitter. I'm happy to help. And thanks for coming out. Appreciate it. So.